talk about the Kreb cycle. It was named in honor of Hans A. Kreb. It is an amphibolic pathway because catabolic and anabolic both reactions take place here. It is also known as citric acid cycle because citric acid is an important intermediate. And other common name for the same group of reactions is the tricarboxylic acid cycle, a term used because citric acid and the isocitric acid both have 3 carboxyl groups. The whole cycle performs in the inner mitochondrial matrix. This is a set of 8 reactions. The reduced coenzymes NADH plus H plus and FADH2 get oxidized in the ETS and produce large number of ATP. Krebs cycle start with the condensation of acetyl coenzyme A and oxaloacetic acid, which is a 4-carbon compound. Pyruvate is converted into acetyl coenzyme A, and this conversion is known as link reaction. This is not a part of Krebs cycle. This is another reaction, that is link reaction. Pyruvate is a 3-carbon compound and 1 molecule of CO2 escapes out and a 2-carbon compound acetyl coenzyme A is formed. This whole process is a hydrogenation process, and the H plus is picked up by the NAD plus, and this will form NADH plus H plus. Now we have 2 carbons. Just consider that we borrow 4 carbon from the oxaloacetic acid. This is a condensation reaction where acetyl coenzyme A and oxaloacetic acid condense together. Now resultant compound is 6-carbon compound citric acid. It is the first stable compound. The enzyme used here is citrate synthetase, which is a condensing enzyme. In next step, citric acid is converted into isocitric acid. This conversion takes place in the presence of aconitase enzyme and a hydrogen molecule escapes out. Now, dehydrogenation of isocitric acid take place and the H plus is picked up by the NAD plus and forms NADH plus H plus. This reaction is a decarboxylation reaction in which CO2 escapes out. Now there is a loss of 1 carbon and formation of 5-carbon compound alpha ketoglutaric acid is formed. And the enzyme used here is isocitrate dehydrogenase. Now, the alpha ketoglutaric acid is further undergoes decarboxylation and CoA enters and 1 molecule of CO2 escapes out. And one thing you should remember that when the process of decarboxylation takes place, dehydrogenation also happens. That you are saying. Again there is a formation of NADH plus H plus. Now the resultant compound will be 4-carbon compound, that is succinyl coenzyme A. After this process, exothermic process takes place, and in this process succinic acid is formed. A GTP molecule releases in this process. Now succinic acid is converted into fumaric acid dehydrogenation takes place and the coenzyme used here is FAD and forms FADH2. Then the fumaric acid is converted into malic acid where a H2O molecule escapes out, and the enzyme is used here is fumarase. Now after that, again dehydrogenation reaction takes place and one NADH plus H plus is formed here. Now the oxaloacetic acid is formed again and the cycle completes here. Now we can see that there is a direct gain of a ATP molecule and 3 NADH plus H plus and 1 FADH2 is formed. So the total ATP count will be in one cycle there are 3 NADH, 1 FADH2 and 1 ATP, and in one cycle 1 NADH produces 3 ATP in the ETS. So 3 into 3 9. 1 FAD produces 2 ATP in the ETS. Yeah, means 2 into 1 is equals to 2 and 1 direct ATP. The total ATP count will be 12. Now in one glucose molecule, from one glucose molecule, 2 pyruvate are formed in the process of glycolysis. So, for one glucose, 2 Kreb cycles occur. So, from Kreb cycle, for one glucose, there are ATP produced are 24. So, and if the question asks that after pyruvate, how many ATP formed are 12 from Kreb cycle, 3 from link reaction, so total 15 ATP, and from one glucose 24 ATP released from Kreb cycle. And here you can see that 3 carbon molecule converted into 2 and the carbon molecules are located here. So that's all. Thank you for watching.